Hello, Algebra 2 friends. I'm sorry I'm not able to be with you today. I am currently at a training, so I am instead going to be teaching you through this video. So first, you're going to take your quiz. As soon as you watch this video, you're going to take your quiz, and your quiz is going to be on the number system. Okay. So quick review of that. You have your real numbers, and then you have your complex numbers. Alright, and imaginary numbers are just pure numbers with I in it. So complex numbers are A plus BI, where A is a real number, B is a number multiplying an I term. Okay? Then within your real numbers, you have your rational, I'm just call it rat, and irrat. Okay? Rational and irrational. Within your rational numbers, you have and rational is any number that can be written as a fraction. So then your irrational numbers are numbers that go on forever, never, never. They don't repeat, like pi, numbers like that. Then rational is any number that can be written as a fraction, repeating decimals, things like that. Then within that, you're going to have your integers. Okay, I'm going to write Z. That means integers. And that's your positive and negative whole numbers. Then you'll have your whole numbers, so W. And so that's going to be your whole numbers, no negative numbers, but including the number 0. And then last is your natural numbers, which are your counting numbers. So those are the numbers that that you use to count. So you start at 1. Oopsie. You start at 1 and you count from there. So 1, 2, 3, 4, 5, 6, on into infinity. So 3,000 is a really huge number. So if it's in the natural numbers, then it's also going to be inside the whole numbers, inside of the integers, inside the rational numbers, and inside the real numbers. So it's all embedded like that. And this is just a really quick review, just to make sure we're feeling okay. Okay. Then you're going to be simplifying your radicals. We did spend a lot of time on that. Okay. So I think we're all pretty good at it at this point. Okay. Then you have your adding and subtracting. Okay. Almost done. And then you're multiplying and dividing your radicals. Okay. Okay, so for your simplifying radicals, you're looking for perfect squares and sets, groups of the size that's indicated by your root. So this is a square root, you're looking for groups of 2. Cube root, you're looking for groups of 3. And then you got to do your tree. Okay, break all your numbers down, and then look for groups of numbers at the ends of the tree. Okay, then you're adding and subtracting. You can only add like radicals, kind of like adding our variables, right? Right, this is 2y plus 5x. I can't add my x's and my y's. So you want to make sure you're simplifying first and then adding everything up, because if you don't simplify, you're going to miss things, you're going to get stuff wrong. Okay, multiplying and dividing, you multiply the outside. So if this is a times the square root of b times c times the square root of d, okay, you're multiplying the outsides, ac, times the insides, bd. Okay, then simplify. So don't forget to simplify. All right, when you're dividing, you get square root of a over square root of b is the same as the square root of a over b. Simplify, then split it up again. Okay, so you're going to combine, simplify your fraction, and then you're going to take the square root and simplify from there. Okay, so I'm sorry I can't be there to answer more questions about it. Please do your best. I know you guys are going to rock it, and I'm really excited to grade them when I get back. So that's that. So what I'm going to do is I'm going to be teaching you your lesson. Oopsie. I'm going to be teaching you your lesson from this video. So if you want to get out the notes page, okay, pause the video right here, pass out the notes page, and then I'll get started with the lesson. So pause right now. Okay, so let's learn a thing or two here, okay? So this is what the first page of your note page should look like, okay? So I'm going to switch between some colors just to keep you engaged. Woo! All right, so as a review, okay, x to the a times x to the b is equal to x to the a plus b. Okay, so that's really simple when we do things like x squared times x to the 7th. That's x squared times x to the 7th is x to the 2 plus 7. Simplifying, that leaves me with x to the 9th, okay? But it gets a little more complex. What if we have fractions, right? So these are called rational exponents, right? Rational meaning you can be written as a fraction. So we're writing exponents as fractions here. So I have x to the 1/3 times x to the 1/4. Well, technically that should be x to the 1/3 plus 1/4. Problem is, that's not quite as simple to add. So we're going to have to do our like denominators like we were doing with our rational expressions. And so we're going to have, we got to multiply this by 4. So I'm going to 4 over 12, x to the 4 over 12, plus multiply this one by 3, x to the 3 over 12, which leaves me with x to the 7 over 12. And that's my answer, okay? So it really is no different. If you can add your fractions, which you should be able to do, you learned that in, I think, 3rd grade. If you can add your fractions, and then if you can remember your exponent rules, then you're golden with this stuff, okay? So down here, this would be 2 to the 2, oops, I couldn't decide what I was going to write there. 2 plus 7, then this is 2 to the 9th, okay? And then you could simplify that further and write me a number, okay? With my rational exponents, it doesn't matter. Here's my base of 2 to the 1/3 plus 1/4, which leaves me with, as we saw above, 2 to the 7 over 12. Okay, and we'll talk in a second about what does that even mean to have a rational exponent, okay? So now, if we recall, all right, and feel free to pause this at any time. If you need writing time, just pause it, keep writing. I'm going to fly through this, though, okay? All right, up here, we have x to the a raised to the b power, okay? And we should know that that is x to the a times b, okay? So with x squared raised to the 7th power, that's simply x to the 2 times 7, okay? And there's a big difference. This is when I have the same base and I'm multiplying the bases. This is when I'm raising the whole thing to a power, so I'm multiplying the exponents there, okay? So that gives me x to the 14th power, all right? Let's do green. All right, so as you might suspect, it works the exact same way with my rational exponents, okay? So I get x to the 1/2 times 3/5, and I'm going to go ahead and put this down here, 1/2 times 3/5. When I multiply my fractions, I just multiply across the top, 1 times 3, multiply across the bottom, 2 times 5, 10. So my answer is x to the 3/10. Okay? And it doesn't change when my base is not a variable. Okay, when it's a number, same thing. Here would be 2 to the 2 times 7, which is 2 to the 14th. Okay, but down here, I'd have 2 to the 1/2 to raise to the 3/5 power is going to be the exact same thing happening here again. So it's going to be 2 to the 3/10 power. Okay? All right, now, when I divide my exponents, okay, when I have the same base and I divide my exponents, I'm going to get x to the a minus b. Okay, so if you go bottom to top, you do b minus a. You go top to bottom, sorry, top to bottom would be b minus a. Bottom to top would be a minus b, okay? So, or 1 over x to the b minus a. So, you can pick either one to do that, but either way, you're subtracting. So, when I do this, x to the 5th over x cubed, I have 5 x's up top, 3 x's on the bottom. That would be x to the 5 minus 3, which gives me x squared. Okay? Same deal going on here. All right? X to the 1/4 divided by x to the 3rd is x to the 1/4 minus 1/3. All right? So that's, I'm going to go, let me do that in a different color. Let's do this in this blue. Hopefully this is dark enough. All right. So I have 1/4 minus 1/3. Okay? Got to change these to be the same denominator, which is going to be, the LCD is going to be 12. So to get this to 12, I got to multiply by 3. To get this to 12, I got to multiply by 4. So I get 3 over 12 minus 4 over 12, which gives me 1 over 12. Negative 1 over 12. Yep, negative 1 over 12. So I get x to the negative 1 over 12. Now, my negative exponents mean I got to flip it over. So if I have x to the negative 1 over 12, that is the same as 1 over x to the 1/12 power. Okay? So, be very careful with those negatives. Again, I'm going to get the same thing happening with my like bases here. This is going to end up just as 1 over 2 to the 1/12 power. Okay? So that's the first page of your notes. Let's go on to the next page. All right, so on this one. All right, these are just two like kind of complex problems here. So first I'm going to break this down. I personally like to get everything into one base first, so I'm going to do what's inside the parentheses first. So x to the 2/5 times x to the 1/4 gives me x to the 2/5 plus 1/4. Okay, and that's raised to 2/7. So 2/5 plus 1/4. I need common denominators, so this is going to have to be multiplied by 4 over 4. So we have to multiply by 5 over 5, which gives me 8 over 20 plus 5 over 20, which gives me 11 over 20. So now I have x to the 11 over 20 being raised to the 2/7 power, which means I got to multiply. And that gives me 20, gotta put the x. X, the 22 over 140, which is equal to x equals 11 over 70 once I take out the common 2. Okay? Down here, not much different. Here we go. So first I'm going to do inside my parentheses. So 2 to the 3/5 minus 2/4. Okay? And all this is still raised to 7/3. So I'm just going to do 3/5 minus 2/4. Got to multiply by 4. 5. So I get 4 times 3 is 12 over 20 minus 10 over 20, which gives me 2 over 20, which is equal to 1 over 10. So now I'm going to rewrite this up here. I get 2 to the 1/10 raised to the 7/3. So now I need to do, let me do a new color here, back to green. All right, 1/10 times 7 over 3rd gives me 1 times 7 equals 7, and 10 times 3 is 30. I can't reduce that, so my new answer here is add 2 to the 1/10 times 7 over 3, and then I found that that was 7 over 30, so 2 to the 7 over 30. Okay? That's my answer right there. All right? So now I want to talk about what does this actually mean? Like, who cares if I can write 2 to the 7 over 30? That's a nifty trick, Miss Anwyll, but when am I ever going to use that? Oh, all the time is what I'm going to say, especially if you make it to calculus. You're going to use it all the time. Okay? So our new rule here is x to the a divided by b is equal to the b root of x to the a, or the b root of x raised to the a power. And this completely makes sense because remember when we were doing simplifying the square root of x to the 11th, right? We said, what's 11 divided by 2? Why on earth would we divide it by 2? And that's because we want groups of x's that are of size 2. So we're dividing by 2. All right, that gives me 5.5, or 5 remainder 1, telling me that my root here simplifies to x to the 5th square root of x, right? So we've been doing this all along. You intuitively already know this, right? We've been dividing those big numbers and seeing how it simplifies, okay? So because this has been true all along, x to the a divided by b, we're grouping it, right? The root undoes the x to the a power, right? It tries to tell us, if I want to know how many groups are going into that exponent, how do I do that? Well, division is how we do it. So we can do that with exponents as well, okay? So let's do some examples. It doesn't work like it does on the smartboard. Okay, let's do some examples. So this is all I'm going to do is write it as an exponent, okay? So I'm raising this. So raising means up, right? So raising that to the 2nd power, and then I'm grouping it into groups of 3. So x to the 2/3, that's simplified. That's as far as I can write it, okay? I'm raising this to the 7th power. So x to the 7 on top. So raising means up on top. Divide by 5. 5th power. X to the 7 over 5. Good to go. Okay? This one, remember this is an invisible 2 here. So on top, I have the 3. And on bottom, I have the 2. X to the 3/2 power. Very bigger. X to the 3/2 power. Okay? This one is just the square root of x, so that's x to the 1/2 power. Can't simplify that. I'm good to go. Okay? All right. Oh, I guess you probably won't be able to see all that. Maybe that. Okay? Now down here, I'm taking the square root, so I have 7 to the 1/2 power, and then x to the 5/2 power. Of course I wrote x. 7 to the 1/2 power, x to the 5/2 power. Okay? And last but not least, my root here is a 4, so that means my denominators are going to be 4. Okay? Let's write my terms here. These are my denominators. Alright, and now I have 9 to the first, so 9 to the 1/4. X to the first, x to the 1/4. Right, there's little invisible ones here. And then y to the third, y to the 3/4. Okay, so I rewrote all that stuff, and that's all well and good. So one thing you should also be able to do is go the other way. So we can go from radical to rational exponents. Now we need to go from rational exponent to radical. So if you go down to the last part of your notes here, all right, x to the 5/11. What does this mean? Well, on top, x is being raised to the 5th, right? And then on bottom, I have to the 11th. So that means the 11th root of x to the 5th. Okay? Then I have x to the 7/9. So on the bottom is the 9th. So that means I'm doing a 9th root of x to the 7th. X to the 7th. Okay? Now, this is really nice because both of these denominators are 4. So if I have the 4th root, okay, I can put these all under the same radical, just like we did on the last page up here. Okay? These all were a 4th root, so they all have the same denominator. So over here, I can put them all under the same radical. Okay? So I have x to the 7th power, y to the 3rd power. And I'm done. All right? Now, 9 here is not raised to a power, so 9 is going to be multiplying my radical. 9, now I'm going to need a cube root here. Cube root of x to the first, so just x, y squared. Okay, over here, 4 is multiplying. All right, we have a 5th root of x squared. Here's my upper number, x squared. And y to the 8th. Okay. Now, this is not simplified. I can simplify this. Okay. So what I'm going to do is I have 4, and now I have at least one group of y's that's coming out here. Okay. 8 divided by 5 is equal to 1, remainder 3. So that means I have one y coming out. So y, and then the 5th root of my remainder, x squared and y to the 3rd, right there. Okay, so that's how they work. They work just like fractions. Okay, they help us to simplify, and I think they're pretty dang nifty. Okay, and you'll see if you take a derivative, it's a lot nicer to take a derivative of a something raised to an exponential power, to a rational exponent than it is to take the derivative of a square root or something like that. Okay, so last but not least, I got these two little janglers. Okay, they have different roots, so I could start by writing this as the square root of x times, and this is all multiplied together, the cube root of y squared, but that's not especially elegant. I don't like that much. So what I'm gonna do is I would like to find a common denominator for these. Okay, so 1/2 and 2/3. So this one needs to be multiplied by 3, and this one needs to be multiplied by 2. Okay, so what this gives me is 3 times 1 is 3, 3 times 2, 6, and then over here I get 2 times 2 is 4, down here, 6. Okay, so now because this is basically writing this as x to the 3/6 times y to the 4/6, and what that buys us is we get to write only one radical sign here. Okay, we have x to the 3rd, y to the 4th. Okay, so that's everything. That's all. Okay, if you ever rewrite like this and then you can simplify, then you should. So that's always the key. Remember to simplify. Okay, but remember to simplify. It's not too shabby. just looking forward from here, you have your quiz today. Next class, we are going to do some review and we're going to talk about some operations with complex numbers. And then on Friday, sorry to do this to you, but the last day before break, you're going to have your test on all this stuff. So make sure you're prepping, make sure you're doing your work, be good with your class time. I don't want to get any reports that anybody was off topic. Good luck with your quiz. And if you need to watch this video again, let's do this. Okay, my YouTube channel is youtube.com/Miss Anwyll Math. Okay, so this will be up there. That's where it's streaming from right now. So go to Miss Anwyll Math. You can watch this video again. And remember, you can always go to the math lab during lunch. You can go to the math lab after school, Tuesday, Thursday. And you can come see me, make an appointment to see me, come during Warriors period. But get the help you need. And let's just make sure we're doing really well on all this stuff, okay? All right. See you on Wednesday. Have a good day, guys.